Welcome back to Probability and Statistics. In this lecture video, we're going to talk about Chapter 2.1, Frequency Distribution. Alright, the word distribution is a way to describe the structure of a particular data set or a population. Sometimes when I use the word distribution, I'm also referring to your table as well. So the word frequency distribution is a display, like a table, of value that occur in a data set and how often each value or range of value occurs. Okay, so the word distribution itself is describing the structure of a data set. All right, the frequency distribution is referring to like a table and such. Okay, so if you look at the next page of your lecture handout, you're gonna see an example like this. Okay, so this whole thing will be called a frequency distribution. So I'm gonna run through the wording of all these topics right here first, then we can go back and forth if we need to. Alright, frequency or lowercase f are the number of data value in the category of a frequency distribution. Alright, the number of data value occurs in the category. Alright, the category that we're going to group our data into is called a class. Okay, a class is a category of data in a frequency distribution. The class width is the difference between the lower limit and the upper limit of two consecutive classes. Okay, I'll show you what I mean in a minute. Alright, the word lower class limit is the smallest number in a class. The upper class limit is the largest number in a class. So if you look at this example, okay, on the top I have my data. The homework problem already group my data into 1, 2, 3, 4, 5, 6 different classes. Okay, so if you look at the first class, the 113 will be the lower class limit of that class. The 1172 will be the upper class limit of that class. So that means the first number of every class is your lower class limit. The second number here are the upper class limits of every class. Okay, the class width is the difference between two consecutive lower class limit or two consecutive upper class limit. You can pick either one. So real quick, what is my class width for this problem? So I'm gonna just pick the first two lower class limits. So I'm going to take my 1173 minus my 1113. So that will tell me my my class limit will be about 60, I believe. Alright, so the width is 60. And the width is the same for every class. Okay. Alright, let's go back. Class boundary are number used to separate the classes. Alright, it is minus 0.5 for each lower class limit and plus 0.5 for each upper class limit. So the example I have, okay, the examples I have, these are whole number classes. Okay, so if if it's a whole number, I use 0.5. If my class has one decimal place, let me just make up a number. Okay, let me just make something up. All right, let's pretend if my class is 22.3 to, let's say, 30.3. Okay, so if my class involving with one decimal place, then that will be minus 0.05 and the other one would be plus 0.05. Okay, so whole number, just add and subtract 0.5. One decimal place will be 0.05. Okay, that's what that means. Since I only have whole number here, okay, since I only got whole number in my example, the class boundaries, okay, we will minus 0.5 for each of the lower class limit and add 0.5 to the upper class limit. So why don't we just go ahead and do that real quick. Alright, let me turn on my calculator. Before I write my numbers in the class boundary, I'm just gonna I am just gonna take my lower class limit and minus 0.5. If I minus 0.5, that will be 1112.5. I'm gonna write it down here, okay? 1112.5. Alright, the next one, I'm gonna take the upper class limit of my first class and add 0.5. That will be 1172.5. The next one will be the lower class limit. If I take that number 1173 minus 0.5, you're gonna notice it will be the same number as the one from earlier. Okay. So I'm not gonna write it down again. So move on to the next one. The next one will be 1232.5. Oops, sorry, not right there. Right here. 1232.5. And if you take the lower class limit of the next class minus 0.5, it will be the same number as that. And what you notice here is, if I go from one boundary to the next boundary, 1172.5 minus 1112.5, it will give me my class width 60. Alright, so that means from one boundary to the next boundary is the same width, okay, as the class width. So if you know that, what you can do here is your first boundary got to be 1112.5. The next one, you just add 60 to it. Alright, 1232.5. So if I add 60 to it, that will be 1292.5. 1292.5 plus 60, 1352. Alright, I'm gonna take this number plus the width again, 1412.5. Okay, so that'll be the class boundary. Alright, and I will explain to y'all in the next video what we use for the class boundary as well. Alright, let's take a look at the next topic. Something called the class midpoint. Class midpoint is exactly what is the middle of your class. It will be the lower class limit plus the upper class limit divided by 2. So lower class limit plus the upper class limit divided by 2. So in my calculator, alright, I'm gonna add up 1113 plus 1172 first, then divided by 2. So my midpoint is 1142.5. The next class, 1173 plus 1232 first, and then divided by 2, 1202.5. And guess what? If I was subtract, put in the wrong spot. If I was subtract my two midpoints, If I was to subtract my 2 midpoint, I actually end up with a class width. That's why we find class width first. It helps us what? To do the boundary and the midpoint. So that means the next one would just be 60 more than the previous one. So 1202.5 plus 60 will be the next midpoint of the following class. 1262.5. Alright, let's add 60 again. 1322.5. Add 60 again. 1382. Let me see if I can type it. 1382. I'm gonna make it smaller. Maybe look a little bit prettier. Alright, that goes right there. Alright, add 60 again. Let's see what I get. 1442.5. 1442.5. Okay, put it right there. Alright. Alright, the word relative frequency distribution. When you hear this word relative, it's referring to the fraction or percentage of the data that falls into a particular class. Okay, so when I use the word percentage, I'm also referring to the word proportion. We're going to hear this word proportion more often down the road. Alright, so if you have a fraction, you can actually divide the fraction. You end up with some kind of decimal notation, and those decimal notation can be converted into percentage. Okay, so so these two different types of numerical numbers will be called the relative frequency. So all we do is take my frequency divided by my sample size. Okay, recall from in other video, the lowercase n is referring to the sample size. Capital letter N means population size. Alright, so for me to find relative frequency, I need to find the actual frequency. So that means we're going to do some counting over here for a minute. So I'm going to scratch this off as I go along, okay? Alright, so I'm going to tally them first, and then I will write down the number. Alright, so 1435. This first data number should fall in where? This should fall into the last class. I'm going to tally. Alright, 1231. 1231. That will be right here. 1470 is the last one. 1286. 1286 right here. 1404 should be this one. 1440 is this one. 1167 is the first class. The next one, 1338. 1338. 1329. 1230 should be the second class. 1323 is that one. 116 right here. 145 there. 144 right there. It's 5. 1422, that class would be. 1299. 1299 right there. Oh, sorry. Yeah. 1299. We'll get confused after a while. 1469. 1159. 1341. That class right here. 1341. 1290. 1290. That class. 1381. That class right there. Alright. So that's all the data. So I got 3 in the first class, 2 in the second class, and 2 in the next one. Five in the next one. In the other one, and 7 in the last one. There we go. Alright, so that's my frequency. Alright, so your relative frequency, okay, will be the frequency divided by the sample size. So there's 1, 2, 3, 4, 5, 6, 7 times 3 is 21. So I got 21 data right here. So your relative frequency, you can do it as a fraction, or you can do it as a decimal. Okay, so 3 out of 7. Let me type it. 3 out of 7. Maybe it's taking too long. Trying to make it nice looking here. 3 out of 7 is the first one. Okay, so you'll get the idea right here. So I'm not gonna actually, it's taking a little bit too long, so I will just write it out. It might be a little bit ugly looking, but just have to bear with me for a minute. 3 out of 7 is the first one. I'm just gonna do fraction. The next one is 2 out of 7. If you can reduce these fractions, you will reduce them. Okay, 2 out of 7, 2 out of 7, 5 out of 7, 2 out of 7, and 7 out of excuse me, not 7. Oh Lord, 21. I don't know why I keep on saying 7. But 21 datas. Alright, let's start over again. Sorry about that. Alright, first one is 3 out of 21. Alright, 3 out of 21 can be reduced. So that will be 1 out of 7. So if you want to use fraction, please reduce it. Alright, 1 out of 7. The next one is 2 out of 7. The next one is 2 out of 7. 5 out of 7. 2 out of 7 again. Oh Lord, what did I say 7 again? Oh, 2 out of 21. Sorry about that. These are 21 datas. Keep on messing up. 5 out of 21. Move it down. 2 out of 21. 2 out of 21. 5 out of 21. And 7 out of 21. 7 out of 21 is if you reduce with your calculator, 7 out of 21, that's my decimal notation. So convert to a fraction, that will be 1/3. So I will do 1 out of 3. Okay, there you go. Alright, so that's called the relative frequency. So remember now why the first one is called 1 out of 7, because it will be 3 out of 21. So if you reduce it, that will be your answer. Alright, that one took forever. Alright, so what is so called the cumulative frequency is referring to the sum of the frequencies of a given class and all the previous classes. It's a sum of the frequency of a given class and all the previous classes. So the cumulative frequency of the very last class should equal to the sample size. So the word cumulative in statistics means accumulation. Accumulating was before. So your cumulative frequency for the very first class still got to be 3 because there's nobody before that. Alright, so now the next class is 2, so you take the 2, add on to the previous one, so that will make it 5. The next one is 2, add on to the accumulation of the previous one, that will make it 7. The next class is 5, add on to the previous accumulation, will make it 12. Okay, that's the idea. Alright, 2 is the next class, add on to the previous accumulation, that will make it 14. Alright, 7 is the last class, add on to the previous accumulation, that will actually make it 21. So the last one should be the same as the same number as the sample size. Okay, that's called the cumulative frequency. Now, if we use the word cumulative relative frequency, okay, a lot is word. If I say cumulative relative frequency, that means we will use, so the word relative means decimal or fractions, okay? Cumulative means we're gonna do the previous one. So cumulative relative frequency will be the first one, 3 out of 21, right? The next one will be 5 out of 21 because the 2 plus the 3 give you the 5 out of the 21. The next one will be 7 out of 21, 12 out of 21, 14 out of 21, and the last one will be 21 out of 21, which is the equivalent of 1 in decimal form. 21 out of 21 is the whole number 1. Okay, so that is looking at the decimal or percentage. Okay, when I use the word cumulative relative frequency. All right, so I think that will be the. I think that's it for us in this video. Thank you for